I hope you read both sides real quickly to see what we're doing. Okay? Having a look first is going to help you learn whether you even recognize it or not. Let's go. So let's review. Yep.
What's the first thing? Is that like
Good. Kind of yeah, you're on the right track there. So the entire article, we looked at this yesterday. We have that check mark sign, not yesterday, 2 days ago. What do we call N? Index. And what do we call the X? Radicand. Okay. Now for a mixed radical, it's the same deal. Okay, except we have an index, a radicand, and now we have y. Y is what we call a coefficient. So for example, if we have 3 fourth root of 5, really what does that mean? Is it 3 plus fourth root of 5, 3 minus fourth root of 5, 3 divided by fourth root of 5, or 3 times the fourth root of 5? It's a times. So it's 3 times the fourth root of 5. So it's a multiplication. Okay, and that's what we're looking at today. So what we're going to do is go from an entire radical to a mixed radical, and then the other direction. It's kind of like if you have a fraction, 9 over 4, and you're converting it into a mixed number, such as 2 and 1 over 4. And then, of course, you'd be able to convert back. It's like that, but it's not the same. Okay, there's different steps, but that's the general idea of what we're doing. Okay, both of them are exact values. We'll talk about that in a second. So some skills that we're going to require. Write the number 3 as a square. Well, 3 and 3 squared, they're not equal. In order to make them equal, we have to use the square root sign. So 3 equals square root 3 times 3. Or you can write it as 3 equals square root of 9. These are all the same thing. Okay, we're going to be playing around with that today. Just like write the number 5 as a cube. So 5 and 5 cubed, how would you get them to be equal? Use a cube root. Okay? Or you could say 5 equals cube root 5 times 5 times 5. It was the same thing. Or 5 equals the cube root of 125. Okay, just playing with your numbers. That's all we're doing. Do this one. Write the number 8 with an index of 5. How many would you have? Jordan? If your index is 5? 5 of them. Sorry. 5 eighths. So 1, 2, 3, 4, 5. Okay. Now we can go the other direction as well. If we have square root 11 times 11, that equals 11. Right? We have an index of 2, and we have a pair. We can take out a single number. Now our index is a 3, and we have a triple. Okay, group of 3. Yeah, Jordan?
So for the last right number 8, would you do like 8 and then 5?
Ooh, shoot. Sorry, that shouldn't be there, right? Is that bugging you?
Yeah.
Yeah, I didn't do that properly. So 8 equals 5 roots, 1, 2, 3, 4, 5. Thanks for bringing that up, okay? Always watch for mistakes, okay? And please let me know right away if something's bugging you. Don't hesitate, okay? Good job, Jordan. Okay, so cube root 9 times 9 times 9 equals 9. Index is 4. What are we looking for? Groups of 4. And since there's a group of 4, what can we take out? Value 6. that's kind of what we're doing today. That's about it. What we're going to do is have prime factors help us a little bit. Okay? So simplifying. This is different than evaluating. Evaluating means the decimal approximation from your calculator. Okay? Simplifying. Okay? Simplifying means write as a mixed radical. Okay. That should be a T, by the way. Okay. So the index tells us the grouping. If the index is 3, we're looking for groups of 3. Then we can take out a single value. If the index is 7, we look for groups of 7. There's several different ways of doing this. Your your textbook does it a slightly different way, and I'll just show you. It's a good way too. Okay, so rewrite using prime factorization. We'll look for groups, and then multiply things together. Okay, that's kind of what we're looking at. So 240, divide by 2, we get 120. Divide by 2, we get 60. Divide by 2, we get 30. Divide by 2, 15. Divide by 3, we get 5. So square root 240 can be broken down into square root 2 times 2 times 2 times 2 times 3 times 5. Okay. Now we're looking for groups of 2. So here's a pair, and then we have some left over. What that allows us to do is take out the single value 2 and another single value 2. And what's remaining? Square root 3 times 5. Multiply everything together, and we get 4 square root 15 as our final answer. Questions? This is brand new. You guys have never seen this before. Next one, square root 48. So let's find the prime factors. Divide by 2. Divide by 2. Divide by 2. Divide by 2. Okay. So now you can rewrite it. As square root 2 times 2 times 2 times 3. What are we looking for groups of? We're looking for pairs, right? Because the index is the number 2. So here's a pair, there's a pair. What's left over? Okay. So multiply everything together. Your final answer is 4 root 3. Okay. Now there's another way of doing this, is you can look for perfect squares within 48. So after you do this a lot, you start seeing it. You say, oh, 48 is just like 16 times 3. So the textbook does this a lot. And lots of teachers will teach this, and I'm even showing you right now. So that's the same as square root 16 times square root 3. Now the perfect square simplifies, right? Root 16 becomes a 4 times root 3, which root 3 stays. Okay, so that's fine too. Just like 75, square root 75, what would be a perfect square with 75? Yeah, 25 and 3. Now a lot of that's guessing. That's why we don't teach as our main method. We can break that down to 25 times square root 3. 5 root 3. Okay. Yep.
When you were the first method, what were you looking for? You were looking at the 2.
Well, the index is 2. That means tells me to look for pairs.
Pairs of the same numbers?
Yeah.
So 2 pairs of each other.
Exactly.
If you had 3s, you would look for, you would just be looking for 2 pairs.
Yep. You want to try this one right now? Let's try that one right now, number 6. Okay. So start dividing. Divide by 2. Now don't lose your index of 3. That's really important. Okay. Be very, very particular. So here we're looking for groups of 3. So we can take out a 2. Cube root 3 is your final answer. Okay. You guys okay with this? 24 is here, which works out to be 2 times 2 times 2 times 3. Yep. Right here. Well, but there's a group of 3 of them, so we take out that number. Okay. All right. You okay with? It's a little weird. I know it's a little weird. So, for example, if I had the 4th root of something that was like 5 times 5 times 5 times 5 times 2 times 2, what would we do? Yeah. So here's 4 of them. So we'd have 5, 4th root of 4. You can, or 2 times 2 and then fix it. Okay? Yep.
How would we do example number 3?
Let's have a look at that right now. So now we're going to get some anomalies, okay? So now we're going to get into some weirder cases, okay? So for number 3, we have 3 square root 32. So what we do is we break down the 32. Divide by 2, 16, divide by 2, 8, 2, 4, 2, 2. So here's a pair, and there's a pair. So this number can come out. Okay, I'm showing you a slightly different way, right? Like, it looks different, but same thing. So what number was already there? The 3, and then we took out a 2, and took out another 2, and what gets left behind at the very bottom? 2. Okay, so then we're going to multiply them all together. So 3 times 2 is 6, times 2 is 12. 12 root 2.
Wouldn't you do 3 pairs if it was,
If I had another one? Sorry?
if it had, oh, never mind.
Yeah, it's not a cube root because the 3's in front of the check mark. Okay. Yeah.
Why did you take the 2 to the bottom?
Is there a pair or is it a single?
What was that stuff we found in the
It is right here. It's not. It can't leave. It can't. If it had a pair, then it can take it out.
Oh, so whatever's left over, you put it in the lid.
Always. Yeah. Okay.
So you just put the 3, you multiply that.
Yep. That's right. Multiply by what you take out. Okay. Okay. Next one's a bit of a weird one. Go for it. Yeah, number 4. Number 4. 42. Done? What's your final answer?
That's what I was going to ask you.
Oh, well, that's what I'm asking you. You don't know? Anyone know? It's a bit of a weird one for sure. So when I divide it, I go divide by 2. I get 21, 3, and 7. Do you see any pairs? Can you take anything out? Absolutely not. So square root 42 equals square root 42. It's as simple as it gets. So you might see one of those. Okay, just throwing that out there. No, not on this. Okay. Next one, root 256. This is going to take a little while. Go for it. See how many pairs there are. So this one's a bit of an anomaly as well, isn't it? Looks to me like I can take out 1, 2, 3, 4 2's. So I get 2 times 2 times 2 times 2. Multiply them together. What do I get? 16. Final answer. Okay. Everything gets cleared on that one. Questions? Okay. Thumbs up, thumbs down, thumbs in the middle if you're unsure. Okay. Okay, so let's work it a bit more. Turn it over. Let's do number 9 to start. Okay, try number 9 first. Go. And notice it ends in a 5. So what number should you start dividing by? Yeah, good. Sure. I'm looking for, the index is a 4, so I'm looking for groups of 4. So here's a group of 4, allows me to take out a single 3. And the one that's left over is up top, it's a 5. So that gets, the 5 stays behind as the root. So technically, really, I should have rewritten this as 3 times 3 times 3 times 3 times 5. Okay? And then I can take these 3's out, but the 5 remains. Okay. So you're not looking at what numbers inside, you're looking at how many there are. Okay. Any questions? Yeah.
Instead of writing the 3 and 4, if you wrote it all, would that be wrong?
Yeah, because this 4 is the index. It's not written like that. See how the 4 is in front? That's the coefficient. Then you'd multiply it. But the 4 is written slightly above the check mark. Okay, it's even with the computer, it's not as clear as when you write it, right? Because when I like to write it, I like to really make sure and kind of cheat a little right inside, eh? But yeah, it stays in the index, and all it does is tell you how many groups to look for. Okay. Any other questions? Okay, good questions. Let's have a look at 10. This might help you. What I want you to do is I want you to expand it out. So a cubed means a times a times a. B4 means b times b times b times b. How many c's are there going to be? 7. So it'll be 1, 2, 3, 4. Okay. So, the index tells us to look for groups of 3. Okay. So here's a group of 3, we can take out an A. Here's a group of 3, we can take out a B. Here's a group of C, we can take out a C. Another group of C, and what's left over? Right? 1B and 1C. How can we write this simpler, though? There's one other thing we should do math-wise. C squared, good. So the best answer is ABC squared. That's a multiplication statement. Letters beside letters are multiplications. Cube root BC. Okay. Questions? All right. Well, let's go the other direction. That may help us going forward. I know there's something we haven't done, but I think we need to move on, and maybe this will help clear up some more questions, okay? So now we have a mixed radical, and we have to bring the 3 inside the square root. So the index shows you how to do that. If it's an index of 3, you have to have 3 of the number. If the index is a 7, you have to have 7 of the number. So what's our index for question number 1? It's a 2. We never write it, but it's there. So in order to bring it inside, we have to have 2 of them. So 3 times 3 times 2. And now you can just multiply them together. Square root 18. Okay. Try the next one. So bring it all in and then simplify it. Sarah, what would you say? Cube root, what's 2 times 2 times 2 times 5? 40? 8 times 5? Okay. Number 3. Okay, complete number 3. Go ahead. Use a calculator if you need to. It's going to be a larger one. Fourth root of 768. Hands up if you got that. Awesome. Good, good, good. Okay. So now what we want to do is we want to estimate again as we compare these numbers in size. So what I want you to do, first of all, is these 3, in order to compare these 3 very well, we need to change them into entire radicals. Okay, so change these into entire radicals. Go. So bring the outside number in. This is non-calculator, so practice it. Okay, so for this one, you might, 49 times 2, it's kind of like 50 times 2, isn't it? So then you have to take away 2 of them. For the next one, it's kind of like 4 times 24. But then or 4 times 25. You have to take away 4 of them. Okay. This one's going to be a pain in the butt. It's going to be 36 times 3. So do some math without a calculator. Three times 6 is 8. Carrier 1, 9, 10. Root 108. Okay. So what perfect square are those 3 close to? They're close to square root 100, aren't they? What's square root 100? 10. Okay. So that's one thing we have to think about. Be aware of where those numbers are. Now, when you compare these 3 individually, which one's the smallest?
C.
B, for sure. Then what do we have? And then finally, C. Okay, that's pretty good. Now let's compare the other two individually. This is the index of 3, so keep in mind this will be 2 times the cube root of 10 broken into 3 equal numbers. Whereas E is 2 times the fourth root of 10 broken into 4 equal numbers. So what's going to give you a smaller number? When 10 breaks itself into 3 equal numbers or breaks into 4 equal numbers? Yeah, E would be smaller, right? For sure, right? Because 10 is breaking down into smaller pieces. So when you multiply this smaller number times 2, you're going to get a smaller number. So now we have E and then D. Okay. So what we have to do now is compare the first 3 with the back 2. We know the first 3 are going to be close to what number? The first 3, they're going to be close to the number 10. So what about the back 3? Cube root of 10. Do we know another perfect cube? What's the cube root of, well, what's 1 cubed? 1 times 1 times 1? 1. What's 2 cubed? 2 times 2 times 2? 8. So we're really close to cube root 8, which is 2. So approximately we have 2 times 2. Right? Approximately that's what we have. So we're somewhere around 4. So should E and D go at the front or at the back? Yeah, because there are a lot. 4 is a heck of a lot smaller than 10. Okay, so we should have here E, D, and then B, A, C. Okay, so what we did is compared within similar groups and then compared the two groups together, estimating.
So the final answer for B and E would be what you have above.
Well, to get the final answer, you would have to go and use a calculator to get the exact value. But for an estimation, breaking 10 into 4 pieces is a lot smaller than breaking 10 into 3 pieces. So when you take this smaller value times it by 2, it'll be smaller overall because this is going to be larger. Okay, that's kind of what we're looking at. Use the idea of the index breaking the number down. Okay. Yeah.
Why did you just ignore the 2? Wouldn't that change the outcome?
In what whereabouts are you talking about? Like ignoring the 2 up here? Yes, but are you talking about ignoring the 2 here when I compare them together? Oh, well, the problem is this is an index of 3 and that's an index of 4. Okay, so we could put the 2 inside. That's another way of doing it. We totally could. It might not be as accurate though, right? Because I'm looking at this thinking, well, why would I? I know 10 broken down to 4 equal pieces is a lot smaller than breaking 10 down to 3 equals. Yeah, totally. You can totally do that. I think we did that a little bit yesterday, right? Like a perfect 4 above and perfect 4 root below. Is that what you're talking about?
Right there where it's 3 indexed and there's 8 and B equals 2.
Yeah.
Wouldn't your answer change if you use 2 coefficients to gain that thing?
That's what I did down here. 2 times 2. Right? So this is going to be like 2.2 maybe. Right? So approximately what we have is the index 2 times 2.2. So 4.4. Right? The only reason why I didn't use this number here was because I knew that like this is going to be way smaller than 10. The only reason why I'm doing this is to see whether ED should be at the front or at the back. Right? Okay, it's a little bit weird. Yep.
I don't really understand why we wrote down the 10 instead of the 2s.
Oh, what I the 10 instead of the 2.
Because I did 2
So what you did is this: is you brought the 2 inside, as you're saying.
Yeah.
Okay, and what does that give you? Cube root what? 160. Okay. And so perfect cube below would be 125. Is that right? Which is 5.
160 is 55.
Oh, okay, so that would be E. So this is, what's 80? Thank you. So what's the perfect cube below? 4. So this would be 64. So this would be approximately what? And 64 and 80. A lot closer than 125 and 80. So probably about 4.2. Right? Awesome. And I got something really close, right? 4.4. So what you did is perfect. Well done. It's just another way of doing it. Okay. I looked at this, like, 'cause I did this last class. And I thought, well, why am I doing all that when I could just do this? But if you're comfortable with that, no problem. Okay. Once you get into the 4th roots, your decimals go up a lot more. Okay. So it gets a little weird there. But again, you should be able to compare and see that just by looking at this one's got to be smaller because you're breaking the 10 into 4 equal pieces. Okay. But what you did is good. All right. Any other questions? Question for you. Is there more than one way to skin a cat? Apparently, right? Is there more than one way to do math? Absolutely, right? I just barely show you the basics, guys. Like, there's so much more to this. It's not funny. But we just don't have time for it because I'd be talking all class. And then you would have tons of homework. More than you're already going to have. Okay? But you're welcome. There's this new device called Google. Welcome. Go ahead. Search it. Okay? There's some good stuff out there.